So hello everyone, welcome to day 6 of the 100-day FPGA series. Today is a special day because today we will be doing a mini project and we will be using all the concepts that we have studied till now from day 1 to day 5. Before we start making the project, let's talk a little bit. We will be making lots and lots of project in our coming days, right, throughout the series. So this project based system is basically here because I want every one of you to be able to design the hardware from yourself. Here also I won't be like don't think of it like I'm making a project and this is hard and fast, nothing. I'll explain to you how to think in that way, how to design a project, how to design the components of a project, right? I want you guys to come up with your own ideas and think like here I'm thinking of making the project, right? I'm here to discuss and I'm here to make you capable of thinking on hardware design level. I don't want you guys to just copy the project. I want you to understand the project and make your own projects, right? So I'll discuss the flow of the projects, how I came up with this project, how I came up, how I made this project with the constraint knowledge of just 5 days that I had, right? That I had to make this project with the only those concepts that I had explained in the first 5 days, right? So this is how I came up with the project. I'm going to tell you that, and again I will show you the project and I'll make the project. So please follow along as well. You guys make the project with me and make your own projects after learning from here, right? Okay, so in VLSI or in fact in any other project making, there are two approaches, right? There is a bottom up approach and there is a top down approach, right? So either you can make a project using all the small components that you have, you can combine them and make a complex system, or you can start with a complex problem and break it down into smaller components, okay, and how you are going to solve that problem, right? These are the two main approaches of making a project. So while you are making VLSI projects and adding it into your CV, you should have a good mix of both of these, right? Something like I'll tell you some examples. Let's say an FFT is a quite nice project. Here you have to think in top down approach because FFT is a concept, FFT is a problem, and you have to think of solution, different components, how you are going to build that project, right? And something like designing your own projects, I'll tell you about bottom up approach as well. Here let's take an example where I have learned basically UART. Let's say I know UART. Let's say I know something related to Hamming codes, okay? Let's say I know something related to fiber optics. I've done something in fiber optic communication like LabVIEW, LVS2. I'll actually show you something optical fiber related in the series as well, so stay tuned for that also. So let's say you have learned all this, right? You can combine all this and make a small project. Let's say a serial communication with Hamming code on an optical fiber. So you have combined all these small concepts and made a project. So this is a bottom up level of thinking, right? You should have a good mix of both of these projects in your CV for your VLSI projects, okay? Here when I had to make design a project which included the concepts of the first 5 days of the video series, which approach did I use? I used the bottom up approach, right? So I started thinking of whatever we have learned. We know MUX, right? And we know demultiplexer, right? So we know multiplexer and demultiplexer, and in the video 2 we had seen interfacing FPGA with Arduino, and we had interfaced ESP with Arduino in that video, right? So we know multiplexer, we know demultiplexer, we know Arduino interfacing. What project can we do using all this? So in olden times, what used to happen in telephone communication as well, they used to use multiplexers, right? They had small switching boxes, and it basically was a multiplexer. So here let's not get into history. Let's discuss what we are going to do in this project. We'll have a multiplexer here, an FPGA with a multiplexer here, and we'll have a FPGA with a demultiplexer here, and we know that a multiplexer gives one output and a demultiplexer takes one output, so we can connect those outputs and inputs, and we can have the selection lines over here. If we send a signal from here using these switches on the FPGA board, if we select a certain signal, we will be able to send it on the single wire, and if the receiver end is tuned into that signal, tuned into that channel, then we will be able to receive the same signal, right? So using this we can make a single wire communication thing, right? Now the next issue comes is that what will be the data source, right? I do not want to go into sequential circuit to generate data source inside the FPGA right now, because we need to learn sequential circuits before that. So what I'm going to do, I'm going to use the Arduino interfacing right here. So what I will do is I'll use the Arduino microcontroller, and I'll send signals from here. Let's say I'm using a 4x1 MUX. I'll send 4 signals from here, and these 4 signals from the microcontroller will go into FPGA, and I'll select a certain signal to be sent on this wire using the selection lines, okay? And if the receiver guy is tuned into that channel at that time, he will be able to hear and he will be able to decode those signals. This will be our project. So this is how I basically integrated all the three concepts in this project. So the idea started from multiplexer and demultiplexer loopback, right? And the problem was that switching the switches, like flipping the switches to generate a signal, was kind of lame. This is also one thing, like you have to make the project cooler, right? So interfacing and adding more and more things to be able to make project more impressive is what you need to do. So I added something that I knew into the project, and now I am generating the signal from microcontroller and passing it to the FPGA. Okay, so this is the entire design. We will be making this, and let's start making this. Okay, so we already had developed MUX and DEMUX in the previous 2 videos. We are going to be using that in here. What I want to do is I want to use 2 same FPGAs, right? I do not have 2 Nexus 4 FPGAs with me, but I have access to 2 Boolean FPGAs. So what we will be doing is we will be turning our project from Nexus to Boolean without creating a new project. So let's see that as well. So if you ever need to change your board in a project, you can change it like this. Okay, so you go to this sigma icon, which is project summary. It may be probably open here, but if it is not, if it, let's say, is not here, you can just go here and click it. Here you will see project summary. Here you can see project part, which is Nexus 4 DDR, and I want to change it to Boolean FPGA board because I just want the symmetry in my project. So that's why. So here I will just go here and click it. Now you can see project device. I can go into these 3 dots and you can change the board here. So I'll change to Boolean board and go here, Spartan 7 Boolean, and just apply it over here. Go into yes. Synthesis will have to be done again since the device has changed. We have gone from RTX to Spartan. Even if we are on Spartan to Spartan, it will be generating again. So here go to OK. Now we are working on Boolean board. This is how you change the board. This is what I wanted to show, a little thing here. Next off we will do is change the constraints, right? Right now we are giving the inputs and inputs of the multiplexer and inputs of the demultiplexer from the switches, right? In a multiplexer we have 4 inputs, and in a demultiplexer we have 1 input and 4 outputs, right? So that 4 inputs from the multiplexer we will be taking from PMODs, right? PMODs, whatever we had learned in the Arduino interfacing one. So here we will take the signal from Arduino, we will connect it into the PMOD, and no, in this situation we are not using the switches, right? We are using the Arduino's signal. Okay, in the DEMUX part we will be taking the input from the PMOD. Okay, and in MUX part also we will be giving the output from the PMOD. So this thing will be a PMOD, this thing will be a PMOD, these 4 signals here will be PMODs as well, right? Only the output on DEMUX will be LEDs. because I do not want to connect LEDs to PMODs. Okay, we will use the LEDs on the board. So we have to change we have to change all the inputs and outputs on the MUX except the selection lines, right? Selection lines you can just keep on the board because you anyways need switches only, right? In here also selection lines will be on the board. The output of the DEMUX will be on the LEDs and the input only will be from the PMODs. So in DEMUX I only need to change this input from, currently the input is set to switches, so from switches to PMOD I have to move the input, and in here I have to move the inputs, 4 inputs and 1 output to PMOD, and these 2 selection switches will remain there only. Okay, so let's make those changes. To make those changes you need to change the constraints, right? Whenever we need to change pins we change the constraints. So currently I am working on a DEMUX, and in a DEMUX I only need to change one input and change this to PMOD. Okay, so I'll go to not the Nexus board, this is Nexus board master HTC, so I do not want this right now because I changed my board to Boolean board. So I'll go to Boolean boards master HTC. So this is Boolean board master HTC and I need to take one PMOD port. So let's search PMOD. Okay, we have PMODs here, we have lots of PMODs here. So I'll take we just need one PMOD, so just take here and I'll just drop it in place of this. Okay, just comment this and set it here, and I will set this to the name that we have given, which is I. Okay, so our demultiplexer change has happened. The output will be the LEDs only and the selection line will be the switches here. So all those things are the same. So I'll have to generate the bit stream over here, and let's just generate the bit stream. Now go to the multiplexer project. Here also I will change it to Boolean FPGA board because I just want to use Boolean. So I'll change it here. Okay, so I just realized we have done something here which is wrong. Actually we need to change everything, right? We have changed the boot, so the pins have changed. So not only the PMODs, I have to change everything, right? So this is we have to change everything. So let's go to here. We need 2 switches for the selection lines in the DEMUX. So I'll grab 2 slide switches. Y0, Y1, Y2 and Y3. In fact the implementation is still running and it will give us an error when it will find mismatch between the pins. So let's see that error as well. Right now I will just change this. Okay, right, again just as I said, there is an error over here, and if we go and see the error, here you can see it has failed to find some ports and all, because some pins do not exist on this board because it is a different board, right? So we need to change all the things if we are changing the boards. I have here changed all the things. I'll generate the bit stream over here and let's move on to the MUX. Okay, the changes in the MUX where I've changed the board. Now I'll change the constraints, right? So we need only these 2 will be on the switches, these 4 will be on the PMODs, right? So I'll grab the PMODs from Boolean FPGA board and let's grab these 4 PMODs. So I've changed the constraints of the MUX as well. I'll just generate the bit stream, right? Okay, so now we have modified the MUX and DEMUX code that we had developed and changed the input and output options from switches to PMODs, right? Now we will be these FPGAs are ready. Now we can just simply connect and wire them up. But now what we need to do is we need to program the microcontroller to send the signals that we want, right? And we will do that using Arduino IDE. So let's get into it. We require 4 pins to send the data signal output. Okay, so I'll declare 4 inputs. So I'll put I1 equal to the GPIO number, which you can see in the pin map of node MCU. So here you can see this is the pin map. I'll be using 5402 over here, GPIO 5402, these fours. Okay, so 5 4 0 and 2. I've defined the inputs and I'll modify them so that we can send the signal. Okay, so first off we'll do pin mode. So now what signal do we need to generate, right? I just need to differentiate. All I want the signals to be able to do is to be able to be differentiable, so that we can tell which signal is being passed. If we keep the signal same, then we won't be able to tell, and how will we say that which signal is being selected right now, right? So what I will generate is I'll have to generate 4 signals, right? What I'm going to do, first signal I'll blink. I'll basically generate 4 square wave signals, right? In all the 4 signals I'll generate 4 square wave signals. The thing is, only I will change the time period over here. Okay, so I'll blink this thing. So I'll turn the first signal on and off at a rate of let's say 100 milliseconds. Okay, and a second signal I'll turn at the rate of 500 milliseconds, third one at the rate of 1 second, and fourth one at a rate of 2 seconds, let's say. Okay, these four signals are differentiable enough so that we can when we decode the signals and see the signals, we can at least tell which signal is being transmitted. Let's write the code to generate all the signals. So I'm going to define smallest period, which is 100 milliseconds, right? I've declared a variable which is the smallest period of all these time periods. Okay, so I'll just do delay. What I'm going to do is I'm going to copy it a bunch of times, and from there I will continue. Okay, so for our first signal we need to toggle it every 100 milliseconds, right? I need to do is I need to set the I1 pin as high. Okay, so it's high right now. Now it needs to change every 100 milliseconds, and so for after every delay I need to toggle it. So this will toggle the first signal high and low after every 100 milliseconds. Okay, so the first signal generation is completed. Now we'll move on to the next signal, which will toggle after every 500 milliseconds. So I'll set the second signal high. Okay, high. Okay, then I'll toggle the second signal low after 500 milliseconds, right? So I need to wait 500 milliseconds. So I'll just count 1 2 3 4 and 5 delays, and after that I'll just toggle the signal to low, right? And after again 5 2 3 4 5 I'll toggle the signal again to high. Okay, and this will continue. Okay, so we have generated the second signal. The third signal, what we need to do is we need to toggle every 10 delays of 100 milliseconds. So again we will do this, and for 2 second signal we need to count 20 delays, right? So we at least need 20 delays, so let's copy and paste 21. Okay, so I have cleaned up the code a little bit, and it is this. Now please if you write this code, please use for loops and everything. I have not used for loops, and I have just used like delay and digital write, so that even the people who haven't worked with Arduino yet at least understand what is going on, and then they can recreate it easily, right? Don't write this kind of messy code, please. Just use for loops. Okay, for like shortening the length. Here I've just used pure logic and repetition, so that everyone can understand. Okay, now this is the code, so I'll put it on the ESP board, and let's see if the LEDs are toggling as the way we like it or not. Okay, as you can see, I'm uploading the code, and I've set up the 4 LEDs in here. to corresponding to 4 different pins. Okay, and now the code is uploaded. As you can see, for the I1, this yellow one is blinking quite a lot, right? It's 100 millisecond on, 100 millisecond off. In the second one, it is 500 millisecond on, 500 millisecond off, and the third one is 1 second on, 1 second off, and the fourth one is 2 second on, 2 second off. So these are the 4 signals that we have with us. Okay, so now we have generated our 4 signals. Everything is sort of done in its own way. Now we just need to connect all the pieces together, right? Do not worry about the Arduino code that I have written. Okay, it seems complex, it's very simple. Okay, and you do not need to write the code. I will provide the Arduino code itself, and there's a very messy code. You can use for loops to write efficient code in here, or you can use millis function to make it even shorter. Okay, so that is there, but again, I am not going into embedded coding right now. Just use the code I have given, and you can even, this is very simple, you can just understand the code. There's nothing too much in it. Okay, so currently I do not have 2 FPGAs with me in my room, so let's go to the VLSI lab of my college, which is an IT Jamshedpur, and let's go into the VLSI lab. We'll take 2 Boolean FPGAs boards, and we'll basically connect everything up, and let's complete this project there. As you can see, this is the setup that I have created. I've connected the 3 hardware, the 2 FPGA boards and 1 ESP to my laptop, and here I've uploaded the code on the ESP, and I've connected the ESP and FPGA through the PMODs using these jumper wires. So all the 4 inputs are basically going into the PMOD from these GPIO pins that I have shown, and it's going into these PMODs over here, which we had assigned in the constraints file in the Boolean FPGA board. And these 2 FPGA boards are basically connected. One is the ground lead, as I've told you that when you connect 2 hardware, you need to connect the ground as well, right? And the second wire, this blue one, is basically the signal wire, right? So this here, when I select channel 0, so there are 4 channels, and the beginning 2 switches are basically control the channel. I'm selected 0 on both the boards, so multiplexer and demultiplexer, and here you can see the fast glowing LED for first signal. Now I change the channel to second, and here you can see slightly slower signal, the second square wave that we had generated. And when I change it to the third channel, which is here 10, it's basically 1 second square wave over here, 1 second on, 1 second off. That was our third signal. And when I move it to 1, this is our fourth signal, 2 second on, 2 second off. This we had set the fourth signal, right? So this is how the data is being transmitted from one FPGA to another using a multiplexer. So we are able to send all those signals using the same blue wire over here. The second wire is just the ground, don't count that. Okay, so just like that, we have completed our mini project, and this mini project included all the concepts that we had learned from day 1 itself. And similarly, we are going to do more mini projects, more such projects that will include a lot of concepts that we have learned throughout these videos. So each video is important in itself, but for these kinds of videos, you will learn how to create a project, how to think about designing a project. Like in starting only, I told you that here the goal is not to copy this project, rather the goal is to learn how to build these projects, right? So hopefully I have given you the ability to think in that direction with the concepts that we have learned, right? So that is my goal. Next off, let's continue our series. We'll do more of combinational logic. So these initial days will be combinational logic and sequential logic, those basic stuff. So we will complete the combinational logic, and we'll do mini projects on the way. Okay, so see you on the next video. Thanks for watching.